The 100 amp sticker found on the indoor load center panel cover indicates that the panel is not designed to handle more than 100 amps of incoming current. The panel's internal components, such as the busbars and breakers, are only rated for this amount. Exceeding the 100 amp limit can lead to overheating, damage to the panel, and potentially an electrical fire. The plan to install a 200 amp meter combo outdoors and use the indoor panel as a subpanel is a common practice but requires careful attention to safety. Firstly, the wiring connecting the 200 amp meter combo to the indoor subpanel must be appropriately sized to handle the full 200 amps. This means selecting conductors with an ampacitive rating of at least 200 amps, as per the National Electrical Code, or NEC. Consult NEC Table 310.16 for proper conductor sizing based on the wire type, insulation, and installation method. Secondly, a 100 amp overcurrent protection device, either a circuit breaker or a fuse, must be installed in the main breaker slot of the indoor subpanel. This 100 amp breaker serves as the primary protection for the subpanel, limiting the current flow to its rated capacity. Even though the wiring from the meter combo is capable of handling 200 amps, the subpanel itself must be protected at 100 amps. Thirdly, it's crucial to manage the loads connected to the indoor subpanel. Do not connect appliances or circuits that, when combined, draw more than 100 amps. Calculate the total load based on the wattage of each appliance and circuit, then divide by the voltage, typically 120 volts for standard household circuits or 240 volts for larger appliances. The sum of these currents should not exceed 100 amps. To elaborate further on conductor sizing, consider the ambient temperature and the number of current-carrying conductors in a raceway or cable. These factors can affect the ampacity of the conductors, requiring adjustments as per NEC Table 310.15b3. For example, if multiple conductors are bundled together, their ampacity must be derated to prevent overheating. The 100 amp circuit breaker installed in the subpanel should be properly labeled to indicate its purpose as the main overcurrent protection device for the subpanel. This labeling helps prevent confusion and ensures that future electricians are aware of the panel's limitations. When selecting the 100 amp circuit breaker, ensure that it is compatible with the subpanel and has the appropriate interrupting rating. The interrupting rating refers to the maximum fault current that the breaker can safely interrupt without failing. The available fault current at the subpanel location should be determined through a fault current calculation to ensure that the selected breaker has an adequate interrupting rating. Furthermore, the grounding and bonding of the subpanel must be done correctly. The neutral conductor should be isolated from the ground at the subpanel, and a separate equipment grounding conductor should be run from the meter combo to the subpanel. This prevents objectionable current from flowing through the grounding system. The size of the equipment grounding conductor should be determined based on the size of the ungrounded conductors, as per NEC Table 250.122. The subpanel should also be properly bonded to any metallic water pipes or other metallic elements that could become energized. This bonding helps to ensure that any fault current will quickly trip the overcurrent protection device. Proper labeling throughout the electrical system is essential for safety and future maintenance. Label each circuit breaker in the subpanel to clearly indicate the loads that it serves. This labeling helps prevent accidental overloads and simplifies troubleshooting. Consider using a circuit directory that provides a detailed description of each circuit. The use of arc fault circuit interrupters, RF size, and ground fault circuit interrupters, or GFCIs, should be considered for circuits serving specific locations such as bedrooms, bathrooms, and kitchens, as required by the NEC. ASIs protect against arc faults, which are a common cause of electrical fires, while GFCIs protect against ground faults, which can cause electrical shock. Regular inspections of the electrical system are important to ensure that it is functioning properly and that there are no signs of damage or deterioration. Look for loose connections, corroded wires, and damaged insulation. If any problems are found, they should be corrected by a qualified electrician. When working with electricity, always follow safe work practices. To energize the circuit before working on it, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work. It is also important to ensure that the electrical system meets all applicable codes and regulations. The NEC is the most widely adopted electrical code in the United States, and it provides detailed requirements for the safe installation of electrical systems. Local codes may also apply, so it is important to check with the local authorities. Another consideration is the voltage drop in the conductors between the meter combo and the subpanel. Voltage drop occurs when the voltage at the subpanel is lower than the voltage at the meter combo due to the resistance of the conductors. Excessive voltage drop can cause appliances to malfunction and can also damage electrical equipment. To minimize voltage drop, use conductors that are large enough to carry the load and keep the distance between the meter combo and the subpole as short as possible. The NEC provides guidelines for voltage drop in branch circuits and feeders. Surge protection should also be considered to protect sensitive electronic equipment from damage caused by voltage surges. Surge protective devices, or SPDs, can be installed at the meter combo or at the subpanel to divert surge current to ground. There are different types of SPD available, and the appropriate type should be selected based on the specific application. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. If you are not sure how to do something, consult with a qualified electrician. A permit may be required for electrical work, so it is important to check with the local authorities before starting any work. The 100 amp sticker is a reminder that the electrical panel has a limited capacity, and it is important to respect that limit to prevent damage and ensure safety. By following the precautions outlined, you can safely install a 200 amp meter combo with a 100 amp indoor subpanel. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Understanding the ratings and limitations of electrical equipment is crucial for ensuring a safe and reliable electrical system. The 100 amp rating is not an arbitrary number, it is based on the design and capabilities of the panel's components. Ignoring this rating can have serious consequences. In addition to the 100 amp main breaker in the subpanel, it's also important to select the appropriate branch circuit breakers for the individual circuits. The size of the branch circuit breaker should be based on the ampacity of the conductors and the load that they serve. For example, a 15 amp circuit breaker is typically used for 14 American wire gauge or AUG conductors serving lighting and receptacle circuits, while a 20 amp circuit breaker is typically used for 12 AWG conductors serving kitchen and bathroom circuits. The NEC provides detailed requirements for branch circuit protection in Article 240. When adding new circuits to the subpanel, it is important to ensure that there is sufficient capacity available. The total load on the subpanel should not exceed 80% of its 100 amp rating, which is 80 amps. This 80% rule is intended to prevent overloading the panel and causing it to overheat. If the existing subpanel does not have enough capacity to accommodate the new circuits, it may be necessary to install a larger subpanel or to run the new circuits from a different panel. Before making any changes to the electrical system, it is important to create a plan and to obtain any necessary permits. The plan should include a detailed description of the work to be done, a list of the materials that will be used, and a wiring diagram. The wiring diagram should show the location of all the circuits, the size of the conductors, and the type of overcurrent protection devices that will be used. The plan should also be reviewed by a qualified electrician to ensure that it meets all applicable codes and regulations. Regular maintenance of the electrical system can help to prevent problems and extend its lifespan. This maintenance should include inspecting the wiring, tightening loose connections, and testing the overcurrent protection devices. The overcurrent protection devices should be tested annually to ensure that they are functioning properly. This can be done using a circuit breaker tester or a fuse puller. If any problems are found, they should be corrected immediately. Remember, electricity is a powerful force, and it should be treated with respect. By following safe work practices and by understanding the ratings and limitations of electrical equipment, you can help to prevent accidents and ensure the safety of yourself and others. The 100 amp sticker is a valuable reminder of the panel's capacity, and it should be heeded at all times. If there's ever uncertainty about what to do, consult a licensed electrical contractor.